Hi there guys. I thought I'll make a little video to give you some help on this question. But let me first explain that this is typically a level 3 type question. I'm talking about the second part. And the thing about level 3 type questions is level 1 is knowledge. That's like just knowing the theory. Level 2 is being able to just apply it in simple applications. So for example, knowing what formula to use, what values to substitute, and then finding the answer. But level 3 is being able to combine different ideas together to address a certain situation. And it usually is a multi-step procedure. In other words, I need to work out acceleration, but in order to work out acceleration, I need something else first. And only then can I work out acceleration. So that's typically our level 3 type questions. So in this one, it is exactly that. Okay, and I'm not going to show you how to do it. There's no way I'm going to show you how to do it because that just won't help you at all. What I'm rather going to do is I'm just going to give you the idea that is often used in level 3 type questions when it comes to acceleration. What we need to understand is that acceleration is affected by Newton 2. So Newton 2 was telling us that an object accelerates proportionally to the net force and inversely proportionate to the mass. So proportionate to 1 over mass. Okay, so in other words, when we're asked a question, that's what we're asking is, do we have net force and mass? Okay, so whenever we're asked acceleration, we basically want to use this formula, net force and mass. Okay, now whenever we want net force, the first question, what most students do is they say, okay, well, net force is equal to mass times acceleration because that's how it appears on the formula sheet. It drives me crazy. Net force is not equal to mass times acceleration. Acceleration is equal to net force over mass. Now, isn't that the same thing? Well, mathematically, yes, it is exactly the same thing. But the problem is what it communicates. This tells me that the net force is dependent on mass. Well, that's not really the case. Net force is dependent on acceleration. What's really happening is that acceleration is dependent on net force. In other words, to get acceleration, I need to first go and work out what is the net force. So, what is net force? How do we get net force? Well, what is net force dependent on? Well, just asking us, what is net force? Net force is simply the sum of all forces. Okay. The sum of all forces that, or the component of the forces that is in the direction of the it's in the direction of motion, or in line with motion. So in any situation now, they ask me for acceleration of a certain object, then what it's going to come down to is I want this, the sum of all forces divided by the mass. Now again, if it's going horizontal, I don't care about normal force and weight. If it's moving horizontally, it's just all of the forces that is in the direction of motion. If there's a force in this direction, then I'll find the component in this direction. If there's frictional force, then it's in that direction. Remember, the sum of all forces is a vector, so if it's in the opposite direction of motion, then I won't sum, I'll subtract. Okay, and so once I get the sum of all the forces and I get the mass, then I'll be able to continue. The trick in this question is sum of all the forces is not so straightforward. You maybe need to look a little bit deeper to find all the forces acting on the object. And specifically in this question, the coefficient of kinetic friction changed. Okay, so in other words, for sum of all the forces, all you'll ask yourself are, what are all the forces acting on here? Okay, the income forces and the expense forces. I write it like that. I like to think about it like that. Adding income forces in the direction of motion, minus the expense forces in the opposite direction of motion. And you might have to go and calculate again. And so if you have to, then while you do, find the mass. How can we find the mass?